Hi devs, in this video I'm continuing the discussion about technical interviews, and I'm talking about a data structure that you will need to know in order to do well in your technical interviews. Today we're talking about the binary search tree, often referred to as a BST. So you'll need to understand how a binary search tree works and its characteristics, its complexity, and so on. So let's talk about what those things are. You'll need to know how to do certain operations with them. Insert an element into a binary search tree, remove an element from the binary search tree, find a specific element, and then also binary search trees, you're able to iterate over them, and we'll talk a little bit about iteration as well. Okay? Before we can figure out how these work and how long they take, what their complexity is, we need to understand a little more about how binary search trees work. So let me describe that for a second. First of all, we have nodes. Draw them as circles, and a node will have a value, say 25. And a binary search tree is called binary because each node can have two children, up to two children. Might have 0, might have 1. And these children will be other nodes. So I can do this, and then this one might have children. Maybe this one only has 1 over here. Okay? Now the thing that's magic about making this a search tree is that the elements on the left-hand side of a node, everything over here is less than that element, and everything over here is greater than that element. So for example, if I had a 12 would go over here on the left, whereas a 40 would go over here on the right because it's larger than the 25, and so on. So I would find something here, maybe 20, and over here 6, and then over here a 30, 35. Okay, so that's how binary search trees are structured. Two children, up to two children. The child on the left is smaller than the current one. The child on the right is bigger than the current one. All right, so let's talk about how would I insert an element into this binary search tree. Let's pick a number. Suppose I'm trying to insert, I don't know, let's go 36. That might be an interesting one. Suppose I'm trying to insert a 36. The first thing I need to do is I need to figure out where it goes. And then once I figure out where it goes, I need to put it in and fix up the pointer so that they point to it. All right. So let's think about how we will find it. In a binary search tree, you're starting at the top, and I'm then looking at doing the comparison. So I say 25 is 36 greater than or less than? It's bigger, so it's going to go to the right. So I'm going to move down the right-hand side. Oh, there's something already there. Is 36 bigger than or less than 40? Oh, it's less than, so I'm going to go to the left. And I come down here, and I have another node there, 35 and 36. Well, 36 is bigger than 35, so it's going to go to the right. So what I do is I insert a pointer on the right, and I add the node here and put 36. And that's how I'll insert it. So if you remember when we talked about complexity analysis, at each step, I come here to 25 and I look to the left and I decide if it's on the left or on the right. Whenever I do that, I'm eliminating about half of the nodes from consideration. Then I go down and I do the same comparison and I'm eliminating half of the remaining nodes and so on. So in this way, since I'm cutting the number of nodes that I'm considering each time in half, then that makes this a logarithmic algorithm. So this is order of log n. Okay? So understanding that, you can figure out now most of these other ones. How would I remove? To remove an element, I'm again going to walk through the same way till I get to the one I want to remove. And then I'm going to, suppose I want to now remove the 36. I'm going to do this same walk down through here. I get to the 36. To remove it, I just simply null out that pointer. Okay, so since that is again going down half of the elements at each time, this is also order of log n. Find should be easy. We had to do that already. We did it twice. So find is, again, just walking down one step each way until I get to it. And so that's also a login. Okay, so those are the basic operations that you do on a binary search tree. Let's talk about iterating. So to iterate, I want to iterate through all of these. By iteration, what I mean is I want to visit every single one of the nodes and then do something with it. In this case, maybe I'll just want to print it out. There are a number of different ways you can do iteration. They're almost always recursive algorithms, and they're done recursively. The one that's the most common is called in-order traversal. It's called that because it will actually output all of the nodes in numerical order. So, and the sequence there is you go left, center, right. And you can imagine then there are other ones like, right, center, left, and so on. So a left, center, right works like this. I get to a node, I go down its left side, and then after I'm done with its left side completely, recursively, I visit the center. So when I hit center, this is where I'm actually visiting the node, and that's where I'm going to do my operation on it. And then once I'm done with that, I go down and do the right hand recursively. So let's start. I start at the top, the 25. The first thing I do is I go to the left, because I'm going the left, and I now hit a new node. So now I'm at this node, I'm going to go left, center, right. Does it have a left? Yes. So I'm going to go down the left. Now I'm at this node, I'm going to go left, center, right. Is there a left? No. So I'm going to go do the center. So 6. So I visited the 6. Now I look to the right. There's no right, so I'm done. So I bounce back up. I've done the left. Now I do the center, which is the 12. Now I do the right. I go down the right. I do left, nothing. Center, 20. Right, nothing. And now I'm here. I bounce back up. I'm done with this node, so I come back up to this one. I did the left. Now I do the center, so I do 25. And now I do the right-hand side. So I'm going to go down the right. I hit this 40, this node here at the 40. But the first thing I do is I look down the left. So I'm going to go down this left. I hit this node. I look. There's nothing to the left. So now I do the center. I do that one. I visit the 35. And now I go down the right. Let's pretend that 36 is still there. I go down the right. Again, left, center, right. Left, center is the 36. Right, there's nothing. I bounce back up. I'm done with this one because I've done the right. Now I bounce back up. I hit the 40. I'm at the center. I hit the 40 and I iterate it. I look. There's nothing at the right. And so I'm done. So there we go. I visited all of the nodes now in order, and that's why it's called in order. Now I've visited every single one of the nodes, so this then is a linear algorithm since I had to visit every node once. So that's that one. So those are the main operations that you would do on a binary search tree. Let's talk for a second about the characteristics of this binary search tree. You can see now that we're keeping the numbers in numerical order, so they're sorted. That's a very important aspect of a binary search tree. So anytime you're working with sorted data, especially if you're trying to insert something into a list that's already sorted, the binary search tree is an excellent data structure to use for that. So you'll want to be thinking about the binary search tree anytime you're working with data that is sorted. You don't always have to sort or to store numbers in here. You could store strings, and then you might do your less than and greater than based on how they compare alphabetically. So anything that you can compare can be put into a binary search tree. So that's the basics of a binary search tree. There's an awful lot more to it. Sometimes they don't perform very well depending on how things are inserted. There's a lot of complexity that can still go into a binary search tree. In most interviews, especially in the more junior positions, those won't come up, so you don't need to worry too much about it. But it would benefit you to study the binary search tree and learn it fairly well. Also, I strongly recommend that you write code for doing all of this. Write code that does the insertion, that does the removal. This code will most likely be recursive. It can be written so it's not, but the easiest and most elegant way to do it is to do it recursively, and so this will give you practice writing recursive code. Because binary search trees work so well with sorted numbers and are very quick when working with sorted numbers, then and because the code is recursive, they very frequently come up in interviews. Oh, there was one last thing I wanted to just point out, just the magic of the logarithmic. So if I have a list that has about 1,000 elements in it, it will take approximately 10 steps to get all the way through, okay, to find any particular element in that tree. If it has 1,000,000, what do you think that might be? 1,000 times bigger. It's only about 20 steps. So the runtime grows very, very slowly, which is another reason that this log n is such a powerful thing to use in a lot of data structures and algorithms. So that's it. Good luck with that binary search tree. Study it hard. It comes up a lot in interviews, and go out and do well in your technical interviews. Thank you.